let me introduce our next speaker, and his name is Anthony Liekens. Anthony, maybe you can join me on stage. That's it. You have been waiting a long time for your talk. We're so happy you're here. Anthony Liekens is a maker and, as your bio says, a mad scientist. He runs the Makerspace in Antwerp, one of our chosen cities for ThingsCon this year, where he helps citizens, organizations, and companies to build smart hardware and to expand business models with smart opportunities. Towards hackable cities. This has been a year for cities for some reason. Since we were all locked up, the cities became our place. Anyway, Anthony, floor's yours.
Thank you. I won't be sharing my screen. I've got some visuals ready, but I'm able to quickly skip to my presentation. Hopefully that works out fine and I don't have any technical issues. Thanks for having me. At first, we were planning on having one of the salons today here in the Makerspace. We have some nice rooms here that would have some workshops and stuff like that. Unfortunately, that didn't go through, but I'm very happy to still be here as our space and talk to you a bit about the stuff that we do. And it will be very practical. It will be very down to earth, not so much academic as in some of the previous talks. I'm more of a down to earth building kind of person. So I'll be talking about hackable cities and what we mean with that. So most of the time, I see that my slide is only partially being shown, but that's good. So most of the time we're working in smart cities, building things for smart cities, and also building things for citizen science, where citizens are involved in the design and taking care of doing scientific experiments and finding stuff. But we were like right in the middle of that, and we're working both in smart cities and both in this citizen science movement. And we're trying to combine them. We're trying to figure out how we can bring citizen science and citizens insights, data collecting by citizens into smart cities and making the smart cities more valuable, more actionable by bringing in these citizens insights. And of course, we do that in co-designing with them, in looking at what the problems are that they're working on and figuring things out and building actual things that they can use and collect data with. So in this we have two partners. So we have the city and we have the citizens themselves. Of course, they're part of each other. But we see when you're talking about smart cities, these people mean different things and do different things. The city has infrastructure, they're building digital twins, they're collecting data, they're trying to build models of traffic and congestion, of dirt in the city and stuff like that. And they have all this nice infrastructure, something that a citizen doesn't have. They don't have infrastructure to collect data or to send data into a digital twin or whatever. And we try to bring these things together, because if you bring these together and if you open up the infrastructure for the citizens to also submit data to, you can gather interesting data that you can, as a city, you can gather interesting data that you can collect. And also for the citizens, it's a benefit because they have a way to put their data to make political choices and pressure based on these things. And so if we can have the cities that are working to become smart cities also involve the citizens, both of them are going to win. The citizens are going to win because they get the data, they get access, and the city wins because also they get the data that the citizens are collecting. But so we want to collaborate and we want to co-design this with citizens. And we have, in the last few years, we've been working on a couple of these projects, similar projects. Some of them have been done in collaboration with IMEC, and IMEC is a big institute in Belgium that works on microelectronics, but they also have a smart cities focus. And one of the projects there that I also initiated with them is the idea of creating a hackable city of things. So empowering the citizens to create a smart city of tomorrow. And we've been doing a couple of experiments, a couple of design sessions together with these citizens to build useful stuff for them and for the city ourselves. So I'll be highlighting a few of these projects that we did or that we're currently in, and some of the results that we had with that. So the first project, and I'm out of screen now as well. Okay, that's okay. One of the first projects that we did is about the 30 zone. So most of the city of Antwerp already for a couple of years is the zone 30. You can only drive 30 kilometers per hour. Unfortunately, not everybody likes that idea of driving 30 kilometers per hour in the city. And we see that a lot of people, and the citizens see that as well, a lot of the people drive much faster than these 30 kilometers per hour. So in Antwerp, we have this action group, this citizen movement called 30 Max, who want to really elevate this idea of 30 kilometers per hour in the city, because it's better for bikes, it's better for safety, it's better for everything. And what they were doing is they had a problem collecting data. They noticed that there was a problem. They noticed there wasn't enough police controls in these 30 zones. And they were doing experiments themselves. They were trying to alleviate this idea of the 30 zone in Antwerp. But they were collecting data with this radar gun. They were trying to collect data by just sitting in the street, standing there with a radar gun and picking up cars and writing down all the speeds that they were driving, and try to convince the city that this wasn't really happening and the zone 30 wasn't really happening. But the city didn't believe them. It's like, yeah, everybody can stand on the street and you can just collect data. And if you put a few ticks on the wrong place, then you get more of your political will that you want to push through. So we need objective data for that. So we started working with them. We started working with this action group and try to design how can we build a radar kind of citizen speed gun that you can put out on the street, measure data for a long time, not just 1 hour sitting there for a long time, collect lots of data and see whether you can do something useful with that. And it's rather useful because you could just go online and buy radars that are certified and are very precise and can actually collect data of speeds in a very specific and very correct way. But then it's not easy. This requires Arduinos, and most citizens are not used to working with Arduinos. So we stepped in and we tried to help them with designing a thing like that. But we were co-designing this with the citizens themselves, and we were trying to fix a few problems together with them. One of the things was, so this is one of the streets where we installed a radar and we're doing our research. And one of the problems is that you can't simply put something, in Belgium at least, on the public domain. You can't just put a device there on the domain or have a traffic pole and put your device on that, because it's all public domain and you can't simply do that as a citizen. So we were looking out around the street, walking around with the citizens, looking around, where can we put this radar? Because there is no place where we can put it out on the street, and we need it to be just next to the street so that we can get good readings of the speeds that people are driving. So we're looking around the street and we see the trees, we see the bikes, we see the trash cans, we see the houses. Not really something that we could use. Until we were walking around there, it's like, well, you can put a bike right next to the street. Why can't we put a radar on a bike next to the street and then collect data from that? And that's what we did. We built a flitsfiets, as we call it in Dutch, a flashing bike, something that flitzes and flashes and collects data of these cars. So we could solve that with putting the radar on a bike, because we could park it wherever we want on the public domain. And secondly, we wanted connectivity. We wanted to push our data out into the cloud. And this is a map of the city of Antwerp with all the Wi-Fi access points that you can find. There is lots of connectivity. Connectivity is ubiquitous, but we wanted something free that people also have. And of course, when you can put one of these bikes in front of some person's house that wants to collect this data, they also want to share their Wi-Fi with the device, and you can use the Wi-Fi of these people. Actually, when we tried asking people, can we put whose house can we use to put the bike in front of them and use their Wi-Fi, there was really a flood of people, and people were really fighting about putting the bike in front of their house. So connectivity was something that we can easily solve if we get citizens involved in that. So altogether, and this picture is maybe a bit confusing. So altogether, we built this kind of box box that you can put on a bike. You can see the 4 screws here inside of the box. We install a radar, and I've taken out the big battery that's sitting down there because it's quite heavy. But with that battery, we can collect data for a couple of weeks. We can install this on a bike, collect data, share it all, and put it all out on dashboards and make it available for the public to see. So here's one of our dashboards. It's not centered, but that's okay. So where they could track live the data that we were collecting with these devices out on the street. And we also had this gathering, and we saw that lots of people were driving too fast. Still now we see that about 25% of the cars that are driving in these zone 30s are driving more than 30 kilometers per hour and could be ticketed. We put it out there, we put it out in the media. One of the striking articles that we got was, well, in 24 hours, if a police officer would be there and put their radar on the spot where we are, you could collect 40,000 euros a day. It was quite impressive. People in politics were quite impressed and scared by these kinds of numbers. But by putting these things out there, we could get objective data, scientific correct data, and we could put some pressure on the politics, along with many other actions that these people from the action group did. And we see now that Zone 30 is more present in the streets now, is more respected, and we have more insights also on what is happening in the city. Another project that we did is about noise pollution. So in the second phase of this Hackable Cities, we asked the people to collect ideas, stuff they wanted to work on. And one of the items was noise pollution in the city, because of course, if you have lots of noise pollution, there's a huge pressure on the quality of life that you had. So we also started thinking with these people, can we measure data? Can we collect data? Can we build a correct device that will collect decibels and make sure that we have a good sight and a good view on the noise in the city. So with them, also together with these citizens, we built what we called a klankentapper. I'm sorry again, it's a Dutch word. A klankentapper is like a sound puller, but it's there is some references to Suske and Wiske there. So we built a device based on a Raspberry Pi. We built our own microphone module because we wanted to have a very precise measuring of these things, because we're working together with IMEC. IMEC is an institute that is known for its scientific correctness, and we wanted to include that. So we've been together with the citizens designing that, where are we going to put the devices, how are we going to get connectivity, so people were putting this on their windowsills to measure data and to collect all this data. As I said, we were very scientific. We wanted the data to be very correct. So together with the scientists, we were able to visit anechoic chambers, test the devices, test the quality of the microphones, look into which microphones were better and decide on that, so that we can have really actual very good data together with them. We built dashboards. Half of my dashboard falls off the screen here. We built dashboards with them so they could live follow what kind of sounds were around them. It was very interesting to see it in lockdown, because in lockdown, when there was no noise in the city, the sounds were really going down. It was a really nice reference point that we could collect data on. But so now these things are out in the field. They're collecting data. They're doing things. The citizens and the citizen movements can do stuff with it. And if you want both of these projects are now open source. You can find them on GitHub. If people want, they can talk to me, and if they want to do stuff like this themselves, we have all the information available. The hardware is documented, the software is documented. So if you want to build stuff like these, you can easily do that. A next project that we're currently trying to initiate, because we're in the very beginning, is on water. Everybody in Germany, Belgium, and the Netherlands know that this summer we had huge flooding going on, and everybody's now a bit freaked out about water. And there are some interesting things that we can do. We want to monitor rain. We want to see how much water there is flowing, because if there's floods coming up, we can do stuff with that. In Belgium, 60% of the households and the homes have a rainwater well installed in their houses. And we want to do some interesting stuff with it, and we're looking into ideas on how we can do stuff with it. Because if you have these water wells that sometimes contain a couple of cubic meters of water, you can use this as a buffering. If lots of rain is predicted, It would be interesting that we can empty out these rainwater wells so that we can use them as a buffer before they go into the sewage systems and flood there. So we're looking into how can we do this together with citizens, monitor this rain, and do some interesting projects along with that. And you can see behind me, we have some setups here where we are already starting to test which sensors we can use in sewage systems to monitor rainwater going into the national system from the people's houses, and how people can be involved in getting that data and collecting that data and getting insights in rain, in flooding, in stuff like that. And also be an active participant in providing buffering for their street, for their houses, for their neighborhoods, by emptying out the rain wells ahead of time and stuff like that. So, but that's just a project that we're starting right now. So all these things, what are we doing? And here again, my slide misses half of it. What we see is that if we democratize science, if we allow people to get to know with science and get involved in science, get to create scientific experiments, we can also make our democracy more scientific. And for me, being an academic, being a scientist, that would be a real thing, that the democracy would be a bit more scientific as well. Thank you. That is my presentation. Thank you for having me.
Thank you so much. Thank you for the enthusiasm, and thank you for those lovely projects. I mean, I have one question for you. I mean, the tools and the technology that you use in those projects have existed for quite a while. I mean, this is not new technology. If you look at the tech field now, is there anything that you see that could result in completely new kinds of citizen science projects? I mean, are there new sensors? Are there new? I mean, is anything new happening, or is this really? It's already there. We just need to get it out more.
We need to get it in the hands of the citizens themselves, because there is. For everything you can find a sensor. For everything you want to measure, there are sensors available. But for citizens, it's usually far away from their beds. It's not easy to access it. It's not understandable. They don't know what is possible or what is not possible. And there's lots of things available for industry, and engineers understand it. But we want to get it in the hands of the citizens and get citizens to be involved in that. Just taking them along in the design process and building these things and building the devices, deploying the devices at their houses, we can see that they can get involved and get a bit more scientific and technological input. So it's moving that from in the hands of the engineers into the hands of the citizens that are not really engineers.
Yeah. And I guess the designers can make it more understandable, easier to use, but in the end, quite a few citizens simply will buy a fixed products, right? I mean, they will not get involved in the design process. They will just say, okay, now I understand, I just buy this, and then it works.
Yeah, but the products that are available never fit the problem that the citizens are owning. They have this radar gun, but it takes, if you're sitting down on the street for an hour with a radar gun, it's not very fun. It's not very believable as well for the city as well, the data that's being collected there. But by improving that, putting more of the science into the hands of the citizens, we can get better data and better involvement of the citizens.
Super interesting. I'm just checking if there's any question from the audience. Ask right now if you have one. Lots of compliments about your presentation.
Very good.
What's the next project you will be working on? I mean, the water project is a big one.
It's the rainwater. So we're looking into monitoring rainwater wells, and also monitoring, because the setup that we have out there is how your house connects to the sewage system in your street. And we want to look where the rainwater is pouring into the sewage system. We want to monitor that. We also want to get citizens involved in what is interesting, what could you do with that? What kind of projects could you do with water, with the rain well, with the water that is flowing into the sewage? Can we do interesting stuff with that? And if you're in a street that has lots of flooding, maybe the citizens themselves can be helping in solving that problem.
Yeah, fantastic. Well, thank you so much. And hopefully next time we'll all come over to the Makerspace in Antwerp.
Very welcome.